Hello dear students, welcome you all. Today we are going to solve the next questions of section B. You can see here the next questions of section B are question number 3 and question number 4, right? Question number 3 is 8 distinguishable particles are distributed in two compartments of equal size, right? Find the probability of macro state 4 4 and 5 3, right? 8 distinguishable particle is basically not printed here, so it is understood that it is uh, talking about the 8 distinguishable particles, right? So these are to be distributed in two compartments of equal size. Find the probability of macro state 4 4 and 5 3, right? They are asking us the probability of a macro state 4 4 and probability of a macro state 5 comma 3, right? So this is the case of the distribution of you know 8 particles in two compartments of equal size. This is compartment 1, this is compartment 2, right? We know what is the formula. We have derived the formula for this distribution. We know very well what is the formula. Formula is uh, P n1 n2 is equal to n factorial divided by n1 factorial into n2 factorial into 1 upon 2 raised to power n. Here n is the total number of particles. So here in this case, the number of particles small n is equal to what? It is 8. And n1 and 2 are the number of particles in compartment 1 and compartment 2, right? So we are starting with the first case, that is 4 4. It means n1 is equal to 4 and n2 is equal to 4. Clear? So if we put all these things here, then you can get from here it will become n factorial means 8 factorial divided by 4 factorial into 4 factorial into 1 upon 2 raised to power 8. Clear? So when you will simplify it, you know how to simplify this expression. You know very well how you can simplify the factorials. So when you will simplify, you will get, after simplification, you will get, so you will get after simplification 35 divided by 128. Clear? So this was the answer. Clear? 35 divided by 128, right? So this was the probability of getting this macro state. Clear? This was simple. Similarly, you can do for 5-3 case. Now in case of 5-3 case, what is n? N is again 8 factorial divided by 5 factorial into 3 factorial. Clear? Into 1 upon 2 raised to power 8. Clear? So when you will solve it, again you will arrive at the result after simplification 7 divided by 32. So this is the probability of getting this macro state, right? So this was the question that I have asked you, and it was of 5 marks. Very simple question. 8 distinguishable particles are distributed in two compartments of equal size. Find the probability of macro state 4 4. So the probability of macro state is what? 35 divided by 128, right? Similarly, the probability of macro state 5 3, it is 7 divided by 32. So this was a very simple numerical problem that is going to be solved by using this relation. P n1 n2 is equal to n factorial divided by n1 factorial n2 factorial into 1 upon 2 raised to power n, right? So there was nothing difficult in this problem, and maximum of you have solved it and got the 5 marks. Now I am coming to the next problem, that is question number 4. Discuss the distribution of 4 different particles in 3 compartments and write down the macrostate, microstate and thermodynamic probability. Now this question is very tricky. It is out of box problem that has been asked here. It was not mentioned in your book. So I want to check your knowledge, that how much you have learned when you have gone through the distribution of particle in different compartments. In our book, you are given the problem of distribution of 4 particle in a in 2 compartment, right? And you have derived this solved this problem, and you have found the number of macrostates, microstates and thermodynamic probability. So when you have solved it, you have found that the total number of microstates in this problem is 2 raised to power n. 2 raised to power n means 2 power 4. 2 is the number of compartment and n is the number of particle. So 4 particle. So in this particular case, it is 60. Clear? So this problem is mentioned in the book that we have solved in the class, but I have told you at that time also that examiner can ask you like this: 4 different particle in 3 compartments. So in that case, this kind of uh, formula will not be applicable here. You have to think differently. So when you are taking 3 compartments, one thing is sure, that now in place of 2 we will have 3 and number of particle n. So total number of microstates will be 3 power 4, that is 81. So 81 possibilities are there of distributing 4 different particles in a 3 compartments. Clear? I have asked you to write down all macrostate, microstate and thermodynamic probability, and I have evaluated your answer books. Many people have tried to solve this problem, but they have not completed because there were 81 arrangements that you have to solve. But I have gave you the credit if you have tried in the right way, right? Actually, my motive was to check your knowledge, that how we can solve such type of problems, right? So now I'm going to tell you how we can solve this problem. So uh, if I take 3 compartments, this this is compartment number 1, this is compartment number 2, and this is compartment number 3, right? So we have 3 compartments. These are different possibilities that we can have here. Many people has answered this question as distribution of 4 particle in 2 compartment, but that was not asked here, and that is wrong. The main thing was you are given 3 compartments. Clear? So this is compartment number 1. This you can take, this is compartment number sorry, you have to take here. This is compartment number 1, this is compartment number 2, this is compartment number 3. Clear? So now we have 4 distinguishable particles. Let the particles are A, it is A. There is some problem. Let me. Okay. So this is compartment number 1, this is compartment number 2, this is compartment number 3, and I'm talking you that we are taking 4 different particles A, B, C and D. These are 4 distinguishable particles that are to be distributed in these 3 compartments which are of equal size, right? Now there are different possibilities. Let's look at the first possibility. First possibility, can you have 4 0 sorry 4 in compartment 2 you will have 0 0. Similarly you can have here 0 4 0 0 0 4. These are different possibilities. Similarly you can have a 1 0 1 3, then 0 3 1, then you will go further, 0 3 1 1 3 0 3 1 0. Clear? Similarly you can have 1 0 3 3 0 1. All these are the possibilities, right? 1 2 3 4 5 6 possibilities are there in this particular case, whereas 3 possibilities are there in these particular cases. Similarly you can have other possibilities like 2 2 0. So in that case you will have 3 different possibilities: 2 2 0, then 2 0 2 and 0 2 2. 3 possibilities will be there. And similarly you can have other options also like 2 1 1, right? 1 1 2. All these possibilities are there. Now you have to look, these are actually what is this? What are these? These are macro states. Clear? These are macro states. Clear? So if you go to the total macro states, you can write these macro states separately uh, in the answer book, like macro state 400, 040, 004, 013, all this. Total there will be 15 macro states, right? Total 15 macro states. Now we are going to micro states. Micro states means when there are 4 particles here: A, B, A, B, C, D. So you know this is the only one possibility here in which this distribution can be there. No way of arranging these 4 particles in this compartment according to their order. It is meaningless. So it is only one possibility. It means only we have one microstate. Similarly, in this case, we will have only one microstate. In this case also, we will have only one microstates. So 3 microstates are there. Clear? Now, if I go to 0 1 3, 0 1 3, now 1 3. Now it is a choice. Suppose in one first case it is A here, it is B, C, D. Now 4 possibilities are there: A, B, it can be V here, it can be C here, it can be D here, and the rest of the things are same as this is the case. So it means 4 possibilities there are. Similarly 4 are there, 4 are there, 4 are there, 4 are there, 4 are. So total 24 in this particular case, 24 possibility, 24 microstates. Clear? For this particular macrostate, right? Complete, I'm talking about the complete this distribution, when one compartment have a 0 and other two have a either 1 or a 3. So total 24 possibilities are there. Similarly if I talk about 220, so in this case you can have 22 means A B C D. Similarly you can have C D A V, AD, BC. Also, all these things are there. So there will be 6 possibilities. Clear for one. So this one macro state. So I told you that there are 3 possibilities of yeah, 3 macro states like 220. I can draw the lines for the right. This is right. Okay. So it was 220. So we can have a 0, 2, 2, and then 2, 0, 2. So 3 different macro states are there. In first macro state, 6 possibility. Similarly, in this also 6. In this also 6. It means 6 into 3, 18 possibilities are there. 18, 24. Right? Now I am going to the next case. That is 2, 1, 1, 1, 2, 1. Clear? 1 to 1 and 1, 1, 2. This is also another possibility. So this is one macro state, one macro state, one macro state. Total 3 macro states are there in this distribution. So when you will go to the distribution A, B, C, D. Now A, B can have, how many possibility? Uh, A, B, here it is C, D, it can be D, C. So all these possibilities are there. In case of AV, you can have here AD, AC. So all these possibilities. So total in this macro state, there will be 12 possibilities. Similarly, here 12 possibilities. Similarly, here 12 possibility. It means total possibility, total number of microstates in this case is 36. Right? So when you will add up all these microstates, 36, 18, 24, right? And 3. Clear? So what you will get? You can add all these possibilities here. It is 3 in the beginning plus 24 plus 18 plus 36. So when you will add all this here, you will get 81. Clear? Uh, right? So this is all about this. How you have to write all these possibilities. Actually, when you will draw this table on the question paper, it will take your answer book. It will take your 2 to 3 sheets. But you can do it. It was not so difficult, right? You can do it in this way, and you will get the total 81 microstates, and you will get 15 total. How much? 15 macro states and 81 micro states. If I talk about the thermodynamic probability, so thermodynamic probability is defined as the number of microstates W, number of microstates in the given macro state. So for example, if I talk about this macro state 211, 211, if I talk about the thermodynamic probability of 211, thermodynamic probability of you can go here W 2 1 1. So how many microstates are there in this macro state? 12. So 12. Thermodynamic probability is a 12. Clear? Similarly, same is the case for 1, 2, 1. Clear? 12. Similarly, you can go 1, 1, 2. Again 12. So this is the way you can write down the thermodynamic probability also. So this was the answer to this question. It was a bit difficult, difficult in the sense that it was lengthy, but it was not that you can't do it, because you know that the distribution of a four particle in two compartment, the same logic is applied here. Four particle in three compartment, number of macrostates, sorry, microstates, 2 power n, here it will become 3 power n, 3 power 4, so it is 81. So in this way you can answer this question. So this was the question that was out of box, that was not mentioned in your book. So all of you have not answered it correctly. Many people have tried, and I have gave them credit if they have tried in the right way. So this was the answer to this question. So well, students, now we have completed the section B. Clear? We have completed section B. Now in the next lecture, we will go to section C and we will try to solve the section C questions. Question number 5, question number 6, question number 7. Clear? Okay. Thank you.